Okay. And I want 2.3 and 3.1 notes. I'm going to pull up and share the screen with you. Give me just a second while I'm messing around with this thing. All right, we're going to share. There we go. Okay. So here we are in section 2.3, looking at stem and leaf displays, last section of chapter 2. It's another visual method of interpreting data or exploring data, okay? Stem and leaf displays, or you might hear them also referred to as stem and leaf plots. You keep hearing me messing around with my mouse there. Stem and leaf plots fall into an area referred to as exploratory data analysis, or EDA. And so techniques are used to explore the data set, looking for patterns of extreme values. And here's the strength. It makes use of rapid implementation. This is stuff you could do quickly, even by hand, depending on your data size. Visual displays and data simplification. If you remember back when we looked at histograms, they're a bear to make if you're doing it by hand, right? Stem and leaf plots, you can get the same information shape-wise of the distribution, but they're really quick, right? So the stem and leaf display is a particular exploratory data analysis method used to rank, order, and arrange the data into groups. I will refer you to example 6 in your book. They take you step by step on how to make a stem and leaf plot. Now for your test in your final, you won't need to make them. I just wanted to show you this, but you do need to be able to interpret the data for whatever the question is asking you. And you'll see that on your practice test, all right? Which, by the way, I think, I don't know if I was recording. For those coming in later that missed today's class, if you go to modules, you'll see practice test. Click on that. There's a practice test 1. Make sure you take it. Look over it. Answers are at the very bottom. I recommend downloading it since you can use it on your test Friday. All right. Let me zoom in on this for you. Complete a stem and leaf plot for the following list of grades on a recent test. All right. Now notice these grades are not in numerical order, and they don't have to be for a stem and leaf plot. But the idea for a stem and leaf plot, let me just go to the side over here. You make something that looks like this. And then if you're one of the undead, you start going. Anyway, okay. There we go. You got your stem over here. And you got your leaves over here. All right. And then what you do is you look at your data. Here's the data we're going to put on our stem and leaf plot. Now notice it starts in the 40s, right? I could have started this where the data started with the 4 and go up through the 10. But I opted to go all the way down to 0 because students could have made a grade of 0, right? Or a 0 with a 1 as a leaf would mean they made a 1 or something like that. All right. You have your stems here, you have your leaves here. Usually, for most of what you see, there's going to be one stem and one pair of leaves, but you also have something that's called a back-to-back stem plot that I refer to. I'm just going to abbreviate. Your stem's going to be in the middle. You'll have a set of leaves over here and a set of leaves over here, and I refer to it later on in the notes, but you have your stems going down here, and then it's like you're taking 2 different samples of data. And for one sample of data, you put your leaves over here, however far they go, and for the other one, you put them over here. And you can compare those 2 groups by looking at the picture. All right. And that seems sort of vague right now, but when you look at the problem that I recommend in your textbook, you'll know what I'm talking about. You need some kind of a key. So for example, here's your stems, here's your leaves. people need to be able to read this, right? And so 7-3 means I have a 7 over on my stem side and a 3 on my leaf side, which means that that's a score of 73. Pretty easy to read, right? Now check this out. I went all the way up to 10 for my stems because there are people that could make a 100, right? And so if there was a person that made a 100, you would put a 10 under the stems and a 0 here for the leaf. But we did not have any, but I wanted you to see that. So then we go to our data and zoom out for this. You just go left to right. 73 means I have a 7 for the stem and a 3 for the leaf. I go to the next data item, a 42. I go down to where, notice the stem is your tens units, right? And your leaves are your ones units. I go down to 4 and put a 2 for the leaf, and so on. And all the way down to the 94 here, I go where there's a 9. Now check this out, there's a 4. You don't have to do these in numerical order. These people for the leaves, they put them least to greatest, 1, 4, 9, not in order of appearance. So check this out. Here's my stem, here's my leaves, here's 10, here's 9. If I was to do the 9s in order of appearance, just so you see this, or do I need a different color? I'd first come to 99, I put a 9 there. I'd come to 91, I put a 1. I'd come to 94, I put a 4. Check this and compare it with this. What's important is you have 3 data items on this side. The order doesn't matter. So if you were doing this by hand and wanted to do it really quick, there's no need to order the data. The shape of this is going to tell you the same information regardless of whether it's ordered or not. Any questions on that? That's if you're constructing your order. Okay, let me clean this up. Here's why I love this PDF viewer that I have on my smartboard. Take a look at this graph. I'm going to rotate it counterclockwise. If you take a look at this graph, it's almost like looking at a histogram that we looked at in a previous chapter, or a previous section, excuse me, right? So you can look at that sideways and actually get an idea about the shape of the distribution, just like if it was a histogram, which is a lot more trouble to make, right? Especially if you're doing it by hand. Histograms can be stinkers, as you saw back in, what was it, 2.1, I guess. Any questions on that? So you might turn, for example, you might flip your stem and leaf plot and see something that looks fairly symmetrical, something like that. The data looks pretty symmetrical, right? Maybe not perfectly. But at any rate, you can get a quick visual interpretation of the data, which is a big advantage of these types of plots. All right, so check this out. Problem 10 and the, well, where whatever page number your problems start at. I know it's an even problem and the answer is not in the back of the book, but it shows you a back-to-back stem and leaf plot. And if I'm recalling correctly, because I haven't looked at it since last semester to tell you the truth, here's a stem, here's a leaf, here's a leaf. You have 2 different sites, like archaeological sites, if I'm recalling the correct example. So you have the stems going down here in the middle, and then the leaves are, what they're doing is like they're digging up artifacts or testing something in the soil to try to figure out how long people lived there and when they lived there. And so it's something like for one of those, I'm going to do a curve instead of bars because it's quicker. For one of those, you had the site where they showed artifacts, and then there was just a bunch of dead space, like nobody lived there. And then they came back and they found some more. And then it might be another one where you know, they lived there maybe during a different time period or something along those lines. It had something to do with archaeology, but I can't remember exactly what. But anyway, the cool thing about back-to-back, you can compare multiple samples if you're using the same measurement system with the same stems and leaves, right? And so I will let you look at that yourself. Outliers. An outlier can be described as data that falls outside the shape of the distribution for that particular variable, whatever variable you were collecting, like depth of artifacts or whatever, some kind of phosphorus amount in the soil or whatever. It indicates a special case that might be worth further investigation. Your ability to investigate outliers to some extent lies with the people who are studying the data. So if they're studying something that they have a background in, like archaeology, they might have a better idea about what do you do with that outlier or how do you interpret it. Okay? Here's an example. So these are grades of students in some class, right? Now, notice what they tell you for the key here. They tell you that stems are 10s. So for example, this person made a 96, right? They don't go into quite the detail as the other one, but they figure people will know what they're talking about. So take a look at this thing. There we go. If you take a look going from students that scored in the 30s up to the 90s, you have a pretty symmetrical distribution there, right? Nobody scored in the 20s, but then you have this poor student down here that made a 16 for a grade. This could be considered an outlier because it falls below the rest of the data where the rest of the data is congregated. And this is a way to put it. Any questions on that? Okay. Potential outliers. So what do you do with them? Well, these potential outliers, by the way, have been redrawn here as a bar graph. For that person that made a 16 is somewhere in this group right here, the 10 to 19 group. So that's their scores. And then you can see two people made between from a 90 to a 99, somewhere in there, right? Notice how the measurement of 16 falls outside the pattern of the frequency histogram and therefore deviates from the overall shape of the histogram. This is an indication that 16 is an outlier in this set of marks, right? So then if you were doing this and you were like, for example, a teacher or a professor, you might be interested in why the heck did this student do so bad with comparison to everybody else? Can the deviation be explained? Here's where the ability to interpret outliers to some extent is based on the person's personal experience and maybe the job that they do, if that makes sense, okay? It could be, for example, the student missed the final exam. A 0 on a final brought him down. The student didn't try any assessment passed through the session. They were lazy, right? The student and the lecturer would then be in a position, or two, I guess I should say is what it says, would be in a position to assess whether one of these explanations is appropriate. Anyone else might not, they say would not, but might not have the relevant information. So interpretation of outliers and what you do with them, how you treat them, to some extent depends on your background experience with the data that you're studying, okay? Outliers can be significant. In other words, maybe the person really did make a 16 and really did do that bad, or it can be a mismeasurement, a typo, right? It could be that somebody meant to enter a 76 and instead they entered a 16, something like that, if that makes sense. So that you would go back and see, well, was it a typo in the data or did the person truly make a 16? Speaking of typos, I always wonder if anybody saw this. Further investigation. I forgot the G, if any of you noticed that. On occasion, I do that. All right? Some of you have me before, you know what I'm talking about. But some of you might want to become private investigators and look at it. Who knows? Yep, I'm on a ball on Monday here. All right. An outlier could be an unusual, important observation. Alternatively, it could be a mismeasurement. And again, understanding the context is important for the person studying the data, right? Do you throw the data out, or what do you do with it? That type of deal. Now, one thing outliers also do is they distort the mean of a data set. The mean is drastically affected by an outlier. So that's why, as we're going to see in chapter 3, when you have data involving money of some type, like income or pricing, things of that nature, how much money as an average employees earn, it's often summarized using the median or the mode, okay? And we'll talk about that in chapter 3. Notice I only gave you 2 homework problems here because, again, your real need is to be able to interpret, not construct one of these. Problems 1 and 10. We'll talk about them Wednesday should you have questions on any of that. In fact, Wednesday we'll whatever questions you might have. Anything on that anybody wants to ask about? Seeing nothing, we'll move on. Now, we're going to start 3.1 but not finish it because part of this is going to be me showing TI-84 people how to do some of this on a calculator, as well as online free calculator people, all right? First, we're looking at 3.1 as measurements of central tendency. There are more than just these 3, but these are the 3 most people concentrate on: the mode, the median, and the mean. Here's where we're going with this, by the way, to tie it in with 3.2. If you know some average of the data, and you know how far apart the data is spread, that tells you something about the shape of that distribution and gives you some information. The next section, we're looking at spread of data. Okay? Just to sort of tie it in. So we asked ourselves, some of us, or I asked you, that's not going to work. All right. Here's what we want to know. Where does most of the data lie? What is the average in quote marks? Because there are different ways to find an average. The 3 averages we're going to look at are mode, median, and mean. First of all, in order of appearance in your book, the mode. It's the most frequently occurring data value. Which number appears the most? It's easy to find. It's not very stable though, because if you just change one of those numbers to a different number, it can drastically affect the mode. It uses specific values of each data entry. Which number it is matters, in other words, okay? All you're doing is looking at the number, seeing which one occurs the most frequently. This is an easy one. Page 90 shows you instructions on finding it. Essentially, you're looking at the data and counting which one ever appears the most. Is the most, right? The median. This is the central value of an ordered distribution. In order to find the median, you're going to have your least greatest numbers down here, and then going this way, you'll have your greatest numbers up here. Least to greatest. It's the very center number, okay? And you're either going to have an odd number of data or an even, right? The median, excuse me, does not use specific values. It uses the position of the data, which makes it extremely stable. If you change the numbers themselves, it usually doesn't change where the middle value is or what it is. Like if you have extremely larger or smaller values. Now, here's an example on how to calculate the median. I'm going to zoom in for this. All how to calculate the median. Notice here, I have 4 numbers. Now in this case, they've already been ordered least to greatest, 1, 1, 2, 5. You might see them out of order. You want them in order to find the median. And then all you do is you find the midpoint. Now, notice this is an even number of data items. You have 4 data items. Whenever you have an even number, your median is going to be halfway between the middle 2 items. This is going to be your median. And so to find it, you take those 2 items on either side and add them together and divide by 2. You find their average, the mean average, I should say. So that would be 3/2 or 1.5. Obviously, halfway between 1 and 2 is 1.5. Any questions on that? Pretty straightforward. And by the way, because some of you might be doing this by hand, when you take a look at your practice test, I don't give you guys a lot of values when you're doing mean, median, and mode. I don't want you spending an hour trying to do it with some cheapo calculator or by hand or something like that. All right, I'm going to clean this up. So notice for this first example, we had 4 data items. Let me make up another example here. 1, 2, 2, 3, 5. It's already in order left to right. Notice here, n equals 5. Whenever you have an odd number of data items, you're going to have a median that lies right in the center where it splits this apart with the lower items down here and the same number of upper items up here. So in this case, my median would be the number 2. Any questions on that? Easy stuff, which is good. Now, I'm going to give you small data sets on your test, but should you be working with large data sets? Well, for one thing, you're probably going to be doing it on a computer and let the computer program whatever find it for you. But just so you know, for data sets of size n, let's say you have 99 numbers. All right. For data sets of size n, the median is the value in position n plus 1 divided by 2. Well, 99 plus 1 divided by 2, 100 divided by 2 is 50. So you'd be looking left to right, what is in the 50th position. That's if the number's odd. If the number's even, you would be like between the 50th position and the 51st position, and you'd find the average of it, that type of deal. Any questions on that? All right. Then let me clean this up. The mean uses the exact value of each entry, and it's not stable. Kind of like me. Extreme values can drastically affect the mean. So for example, extremely small values can skew your data to the left, like this. Extremely large values can skew your data to the right, like this. Right? How do you find the mean? This is what most of us think of, by the way, when we say average numbers. You add all of your numbers together and then divide by however many there are. Sum of all entries divided by the number of entries. Notation-wise, you have a sample mean represented by X bar, the X with the bar over it. We talked about that. This sigma symbol means you're adding things together. You're adding all of your X values together and dividing by the sample size, which is denoted by a lowercase n. Your population mean is calculated exactly the same way. They just use different symbols. Instead of X bar, that's represented by the Greek letter pronounced mu, which I'm writing in mu, okay? It's the sum of all your x's divided by sample size. Check this out. When you have a population, your sample size is capital N. When it's a sample, you're referring to it with a lowercase n, but you're doing the same computation, adding all the numbers together and dividing however many there are. Any questions on that? All right. Now your book goes into talking about a trimmed mean. Because of the fact that high or low data values can skew your distribution, like if you have extremely high values, it will skew the mean higher. What they'll do is they'll take some percentage of the lowest values, some percentage of the highest values, and just take them out of the data set and essentially find the average of what's in between. Like they might cut off the lowest and highest 3% of data to get rid of outliers, and then take the mean of what's left in the middle. So you get something more stable and not worrying about outliers, right? You got to be careful about cutting out outliers though, and know, you know, how that could possibly affect it and what really caused the outlier. But anyway, your book talks about this idea of trim mean. All right. See if I can do this. Bear with me while I change my share to a calculator here. Hopefully you'll be able to see this. All right. I think I just shared the calculator. Stop. Let's try it again. What do I want? I want the actual screen. Okay. So you should be seeing a calculator on top of notes. If I'm correct, and hopefully I am. Let's see, who can I click on here? Alexis, can you see the calculator and the notes?
Yes.
Awesome. It's actually working. All right. So here's your example. Find the mean, median, and mode of the following data set. Well, for mean, you don't need to order the data set. I'm just going to add the numbers together. And again, this is probably about the speed of what you see in the test. Add your numbers together. You get 39. Divided by, what is it, 9? Divided by however many there are. If I did that right. And you get 14. That would be the mean. Add them together, divide by however many there are, right? And now notice this is one of these really easy calculators that Windows has, right? Let's talk about the median. All right, for the median, this data has to be ordered. So let me do that here. So here's the 1. What's next? The 2, 3, 4, 5, 5, 5, 7, 7. And I want the very middle piece of data here, right? It's going to be this 5. Notice there's 4 down here and there's 4 up here. So this would actually be my, what did I just find? The median. Right? For the mode, you don't need to rearrange the data. You just look and see whichever one appears the most. In this case, we have 3 5s. That's the most the data value appears. So my mode would be 5. Not bad. Any questions on that? All right, now,
Mr. Sh- Mi-
Yeah.
Mr. Shriki, I have no question, but can you please give me a few minutes to copy it down?
Yeah.
Thank you.
And keep in mind, this is being videotaped.
Yeah.
So you could look back and watch it with a bowl of popcorn.
I'm good. You can go ahead.
Awesome. And you can still have a bowl of popcorn if you want. All right, here we go. So what did I want to do here? Let me do this. I'm going to clean this up. All right. I hope I can do this without it, but we'll find out. Let's do this. I need to stop share to try this. I think it might mess it up. Get rid of that. Get rid of that. Let's get rid of that calculator. And I'm going to pull up a graphing calculator here to show graphing calculator people how to do this. Let's see, what do I want to do now? I think I want to share the screen. Last time I tried this, it froze up to have both of these. What you should see on the left is the data that we want to find the mean, median, and mode, and then the graphing calculator on the right. If there's anybody that cannot see the graphing calculator, please let me know. All right, excellent. Graphing calculator, here's what you do. You should see the buttons change colors when I push them. There's a key that says stat. It's underneath the delete key. If you press stat, well, try it again, press stat. Arrow, I'm sorry, it's already on edit at the top. You see it says edit and option number 1, edit. You'll go and press enter. By the way, this is under modules of videotapes on how to do all of this different calculating stuff. So this is entering data in the list. See that there's already data on that list. Check this out. This is important. We need to clear it. Arrow up and highlight the name of the list. You now see L1 is highlighted. This is also important. You don't want to delete the data. You want to clear it. I'm going to press the clear key that's right over here by the vars key. Here's why. If you press delete, it's going to delete the entire list. Right through the name of it. All right. So press clear. Press enter. No more data. Now we can enter the data from our problem. So I'm just going to enter it in order of appearance. So I've entered the data. Now we're going to press stat again. Stat. At the top, we're going to arrow over to calc. By the way, the button pushing stuff is also in your textbook under the technology sections that appear in sections. Arrow to calc. We want option number 1, single var stats. You're going to run into this a lot through the course. We're going to press enter. Now, here's where some of the 84s differ. Mine has the list defaulted as list 1, which is where my data is. So that's what I want. Arrow down, it says freq list or frequency list. We're not even using that for this problem. Arrow down to calculate and press enter. All right. X bar, that's the mean. It gives you the sample, even though it might be a population. Okay, so they're calculated the same. X bar is 4.33. That's the mean of this data. Well, approximately tells you that. All right, we want the median. I'm going to arrow down and find something called median, MED. The median is 5. And here's where TI calculator technology fails us. It won't tell us the mode. So you have to actually go back and count the data for the mode. Just so you know. This stuff we're looking at right now with the mins and maxes and medians in Q1 and Q3, we're going to see this later in chapter 3. Okay. Anyway, so here it is on tape, and you also have the video on your modules under the TI calculator videos. Any questions? Awesome.